Okay, so there's three new rules that 4.3 introduces. I mean, it has to do with really still simplifying logarithms, but there's just three more rules. And I'm going to go through them with examples, and we're going to bring in stuff from 4.3, the simplifying examples from 4.2. We're going to bring in simplifying examples from 4.2 as well. So the first rule is called the product rule. Got the L. There's an L. Okay, the product rule. And the product rule says, look, if you have a logarithm, let's say like log base b of m times n, and you have multiplication on the inside, you can actually add, or how would you can actually, what's the word here? Expand the logarithm actually with addition. So this is equal to log base b of m plus log base b of n. So this is expansion of logarithms. And that's actually the first part of the homework. Your book is going to ask you to expand and simplify. Okay, expand and simplify. What that means is we're going to go from a single logarithm, expand to multiple logarithms, and then simplify each one of the logarithms. So let's look at an example of that with this multiplication. Let's say I had log base 2 of 16y. Okay, log base 2 of 16y. And we're going to use this product rule because the 16y, they're really being multiplied. The 16 and the y are being multiplied inside the logarithm. So you'd have log base 2 of 16 plus log base 2 of y. Right? That was the product rule. And now we're going to look at both of these. And we're going to say, hey, can we simplify the first logarithm or the second logarithm? Well, if I look at this first logarithm, remember back from that first section, or section 4.2, I should say, from Tuesday, that we can simplify this if we can get 16 into a base 2, which we can. 16 is 2 times 2, 4 times 2, 8 times 2, 16. So it's 2 to the 4th. Okay? Now, log base 2 of y, we cannot simplify. The 2 and the y are different, and you can't get a y into a base 2. Y is a number, okay? But this first logarithm, since we have the matching bases here, remember this all cancels, and it leaves us with our exponent. So 4 plus log base 2 of y, okay? So look, we use the power rule to expand, and then we simplified using the rules from yesterday. This all goes together. Okay, today it's going to all go together. And again, we're not solving for anything. That's the next section. We're just simplifying. Okay, we're not solving for anything. We're not solving for y or x or z or anything like that. We're just simplifying these logarithms. Okay? Questions? Look at this color. It's popping. Okay. So if the product rule means we add, you can probably come up with what happens with the quotient rule. The quotient rule says, look, if we've got log base b of m over n, we subtract, right? So division inside means subtraction on the outside. Log base b of m minus log base b of n. Okay, so let's look at an example where we do the same thing. We're going to expand and simplify again, but we're going to use the quotient rule instead of the product rule. So let's say we had the log of 100, or not 100, let's say 10. Log of 10 over z. Log of 10 over z. Okay, so now remember, if log is by itself, that means it's log base 10. Okay, we have to remember that for the simplifying part. Now for the quotient part, we've got division on the inside. So that's going to become log of 10 minus log of z. Okay? Log of 10 minus log of z. And we know we can simplify that first one, right? Remember, really the bases match here. I'm going to use a little different marker. It's a little like pen marker. Remember, you can think of a 10 being here if you want. Okay, there's nothing wrong in writing a 10. if you want to. That's no big deal at all. But these match. You remember when they're the same, it just simplified to 1. Now, log base 10 of z doesn't simplify, so it's just log of z. And we are done. Okay? Questions, comments, or concerns before I do another one? Okay, I'm going to combine both of these now. We'll do ln. We did log here. Let's do ln that we talked about last time. Let's do that here. Let's say we got ln of 2x over e to the 5th power. ln of 2x over e to the 5th power. Now look, we've got both going on. Notice we have division, so we're going to definitely subtract here. We also have multiplication in the numerator. We've got ln of 2, we got the 2 times x, I should say. So we got multiplication up top, and we have division. So here's how we're going to separate this one. We're going to say the top is being added. Well, actually, I'm going to break it down like this. I'm going to say ln of 2x minus ln of e to the 5th. We're going to do division first. Right? That was the roll up here. So let's do division first. Top minus bottom. Now we're going to simplify it. And actually, we can expand out this first logarithm with the first rule, the power rule, right? I'm not the power rule, but the product rule. Power rule we're about to get to. But we're going to expand this out with the product rule. It says ln of 2 plus ln of x minus, now look guys, I'm going to simplify this one now. Ln and e, you can think of those as kind of canceling each other out. So ln and e cancel each other out. And it leaves, because ln is log base e, that's why it cancels each other out. And it leaves you with the 5, okay? And look, we're done. Ln of 2 can't simplify. Ln of x can't simplify. And 5 is simplified. That is our simplification. We've expanded and simplified, okay? Now, I'm going to give you a few examples here to try on your own just to kind of see where you're at, okay? It's okay if you get these wrong. It's okay if you go about them a little differently than I do and get the same answer because they're all a little different, okay? So let's look at one like that last one. Let's say, let's do one that I haven't really talked about. Let's say we've got log base 2 of 8 over, let's do 8 over xy. It's a little different. And then let's do another. I'm going to choose one from the homework to make sure I'm not choosing some that are just totally in left field. Okay. Yeah, this is number 6 in your homework. Log, this will be a little first. Log of 10,000 x. And then, since that one's going to be a little easier, let's do one here. Let's do, okay. This is number 14 in your homework. Ln of e to the 4th over 8. Okay, try those 3. I'm going to give you a few minutes, actually, to try these. With the 2 rules, the power rule, the product rule and the quotient rule. We're about to get to the power rule. Try those 3 with the power, the product, and the quotient rule. Okay, I'm going to start these. This first one actually is the most tricky one compared to the other two. So log base 2 of 8 over x minus y. So I'm going to split it up from the division first. So it's log base 2 of 8 minus log base 2 of xy. Now, think about this. If you're subtracting both of these, I know this is addition right here, right? But you're going to have to subtract both. So now log base 2 of 8, that's going to be 2 cubed. That'll be nice. That'll simplify. But it's going to be minus, and you have to subtract both. So log base 2 of x plus log base 2 of y. So both of these are going to become minus, going to become subtraction, I should put it that way. The first term, though, log base 2 of 8 becomes 3 minus log base 2 of x. And then it's going to be minus log base 2 of y. So a shortcut to kind of do this is if it comes from the denominator, it's going to be a minus coefficient, okay? Since that x came from the denominator, it's going to be a minus log base 2 of x. And the y is in the denominator, it's going to be a minus log base 2 of y. Now this first one is simplified. 8 is 2 cubed, so that went away and left us with 2. Questions? That's a tough one. That's not easy. If you got that one right, you need to give yourself a pat on the back, okay? And know that you're going in the right direction. Now the next one, though, it's just multiplication. So it's going to be log of 10,000 plus log of x. Now log of 10,000, what's nice about log is it's in our calculator, right? So I'm going to be efficient. I'm going to use the calculator. And I'm going to say that log button, not store button, the log button, and then just put in 10,000, and I get back 4. Because 10,000 is 10 to the 4th power, okay? This is 4 plus log x. And that's it, okay? Then ln e to the 4th over 8, that's going to be ln e to the 4th minus ln a, right? Now, ln e to the 4th, just like before, the ln and the e cancel each other out because ln is really log base e, okay? ln is really log base e, so it cancels with the e, and it leaves you with that 4 minus ln. Okay, now ln and 8 doesn't cancel. You can find this number. It's going to be some irrational number, right? You can pop this in the calculator. You'll get a number, but we're going to stop here. Okay, any questions about these before we go on to the last rule? Any questions before we go on to the last rule? I'll sit here, park it here for a minute. Let you think, let you marinate. Okay. Okay, so the last rule that your book talks about for the simplifying logarithms is called the power rule. The power rule. And it says, look, if you've got log base b, and we don't have another b in here, let's say we got like that m raised to the x power, okay? So if the bases don't match, you can actually bring the x, the power turns into multiplication, okay? You can bring the x out to the front, so it becomes x times log base b of m, okay? So a really, really basic example of this would be like log base 2 of 5 cubed, okay? Log base 2 of 5 cubed. Well, log base 2 of 5 cubed, see how the 2 and the 5 don't match? You can't simplify. You can't say this is 3 because the 2 and the 5 don't match. But you can bring the 3 to the front. So you can say 3 log base 2 of 5, okay? And I'm going to throw some out here. Just this kind of reviews a little bit from yesterday's material, or not yesterday, but Tuesday's material. So if we had like log base 3 of the square root of x, we wouldn't, if we're simplifying these or really expanding them completely, we're not going to leave a square root in there. We're going to automatically think of that square root as an x to the 1/2, right? Remember, square root, you can write any root. You can write is 1 over whatever the root is. So if it was like a fourth root, it'd be 1/4. Cube root, it'd be 1/3. Now I'm going to bring the 1/2 out front and say this is log base 3 of x. Okay. Let's see if I've got another one in here. Oh, we can do one that kind of combines both of these. Let's say we had ln, let's say the fourth root of ex. So we have two things on the inside that are being multiplied. So we'll get there. But the whole thing inside this ln is being raised to the 1/4 power. So the very first thing I'm going to do is think of this as ln of e to the x raised to the 1/4. Okay? So right off the bat, I'm going to write this root as an exponent. And then I'm going to bring that exponent to the front. Okay? And now I can break apart the exponent into multiplication. Now be careful. This 1/4 is going to be multiplied to everything. Okay? Not just the first term. The 1/4 has to be multiplied to all terms. So it's going to be ln e plus ln x, right? But that 1/4 has to be multiplied to both those terms. So I'm going to distribute it through, and I get 1/4 ln e plus 1/4 ln x. Okay. And now we need to see if any of these simplify. ln e simplifies, right? Remember, ln and e cancel each other out. So this would leave us with just 1 here. So if I want to, instead of having to write it all over again, I can say, hey, look, this goes away and leaves us with 1. So you get 1/4 times 1, that's 1/4, plus 1/4 ln x. Man, that was a little more difficult than I thought. It took a few more steps than I realized. Okay, and there's nothing wrong with that. It's a good example where we've got the power rule and the product rule kind of embedded inside the power rule. Okay, question. Okay, I'm going to just find some examples where it kind of combines all three of these rules, or maybe 2 of the 3, and go from there. So let's say we had, this is number 24. Log base 5 of the square root of x over 25. Log base 5 of the square root of x over 25. So the question is going to say, use properties of logarithms to expand each logarithmic expression as much as possible. Where possible, evaluate logarithmic expressions without using a calculator. Okay? So we're going to do that. So let's expand this completely. Now look, we have division first because we've got a top divided by a bottom. So I'm going to say log base 5. I'm not going to call this the square root of x. I'm going to say it's x to the 1/2 because we need to get in that habit of automatically writing roots as exponents minus log base 5 of 25. Okay. Then I'm going to see what I can simplify. So this first one, I can bring the 1/2 out to the front. 1/2 log base 5 of x. Now the second one, I can write 5. Now I'm going to be a little lazy again. I'm not going to rewrite everything. I'm going to say 5 here, or 25 here, can be written as 5 squared, right? And because 25 can be written as 5 squared, I chose 5 because my base is 5. Because these match, it leaves me with just 2. And I'm done. Yay. The crowd goes wild. Mr. Shirley does it again. Okay. Question, comments, and concerns. Okay, let me give you one to try. These are getting boring. Okay. Let's say I've got log base 8 of 64x to the 4th power over, let's say the square root. Actually, let's do like the 4th root of y. So I want you to expand this completely and simplify. And I'll give you a minute. Expand this completely and simplify. Okay, let's see here. First, I've got division, so I'm going to do that first. Log base 8 of 64x to the 4th minus log base 8. Now I'm going to write that 4th root of y as a y to the 1/4. Now I'm going to separate this out, but there's multiplication in here. So I've got all three things going on. Log base 8 of 64 plus log base 8 of x to the 4th minus log base 8 of y to the 1/4. Now 64 is 8 squared, right? I mean, I could write this as 8 squared. So therefore, the 8 and the 8 cancel, leaves me with the 2. The second term, the 4 can come out. So 4 log base 8 of x. And the last one, the 1/4 can come out. That's a minus because it was in the denominator. So 1/4 log base 8 of y. Okay. Oh, I didn't mean to mark that out. Any questions before I keep rocking and rolling? Okay. Now, look, we can expand. That means we can condense. So we're going to go the opposite way now. So I'm going to give you a more than one logarithm, and then we're going to condense it out into a single logarithm. So a very, very basic example. This is like number 42. This is log of 250 plus log of 4. So notice we have more than one logarithm, and the question's going to state, now I'll read this whole thing. Use properties of logarithms to condense each logarithmic expression. Write the expression as a single logarithm whose coefficient is 1. So we got to make sure we have a singular coefficient of 1. Where possible, evaluate logarithm expressions without a calculator. So now what this means is if we're going to condense these, the coefficient in front has to be 1, which this doesn't, we don't have to worry about it here. But if we did, we know we could bring it inside as an exponent. So let's look at one like this, kind of a basic one, and I'll do one here next with a coefficient. Now we know with a plus sign, that means same logarithm, log base 10. A plus sign on the outside meant multiplication on the inside. So this is going to be 250 times 4, right? So we can condense these. Look, if we want to go backwards, look, you got 250 times 4. It separates into an addition side on the outside. 250 times 4. That is 1,000. And we know log of 1,000, you can pop it in your calculator, but 1,000 is 10 cubed. Okay, this is like saying 10 cubed. And then log base 10 of 10 cubed, the 3 cancels. So, or the 10s in the log cancel. And that leaves us with 3. Okay. Okay, now let's look at one with a coefficient. Let's say we've got 2 ln of x minus 1/2 ln of y, okay? 2 ln of x minus 1/2 ln of y. So I'm going to bring the 2, okay, before you get started on this, you have to get rid of the coefficients. So you have to bring the 2 up front and the 1/2 up front. So we get ln of x squared minus ln of y to the 1/2. Okay, now it's a minus. So up here was addition. Same logarithm, ln, but we got a minus, and we know addition became multiplication inside. Subtraction is going to become division. So we wind up with a singular x squared over y to the 1/2. And we know y to the 1/2, that's just the square root of y. So they're going to want us to end it in radicals. I don't know why your book does that, but whenever you condense it, they move it back into radical form. I have no idea why. On a test, just be ready for both. You know how to do this. We know how to go from radical to exponent form. So just be ready for either one on the test because it's multiple choice, right? You're going to have to line it up with that answer. Oh, and the last topic today is going to be on the change of base formula. The change of base formula. What the change of base formula does, actually, it makes it where we can write any logarithm in our calculator to get an approximation. So to do this, I use ln. It's in your book on page, hold on, let's see. Just have a reference. Yeah, it's on page 475 in your book. And what you can do is actually you can write a ratio of ln's if you want to get the actual number. So let's say we had log base 2 of 5, okay? And for some reason, I needed an approximation. Maybe I needed to graph it. I need to know exactly kind of where it's at on the number line, or for whatever reason, I need an approximation. And we know log base 2 you can't pop in your calculator. So what you can do is you can use, your book calls them common logarithms. We're going to use ln to do this. And you take the ln of the top, so that's, I'm sorry, ln of what's inside the logarithm, over ln of the base. So ln of 2 over ln 5. So I can do that in my calculator. I can't do log base 2 of 5 in my calculator, but I can do ln of 5 and ln of 2. So ln of 5, and I close the parentheses, divided by ln of 2. And when I do that, I'm going to round to 4 decimal places. So I'm going to say it's approximately, because it's not exact, right? So I'm going to use that approximate notation. 2.3219. Okay, 2.3219. So if I wanted an approximation of log base 2 of 5, it's roughly 2.3219. Now it's kind of fun to check these, or I say fun. You can check them. So if I think log base 2 of 5 is roughly 2.3219, I can write this as an exponent to see if that's close. So remember, so this brings up stuff from last section. If I want to write this logarithmic equation, or approximation, I should say, as an exponent, it would be 2 to the 2.3219, and it should be close to 5. So I'm going to pop that in my calculator. 2 raised to the 2.3219. You'll notice we get 4.9999902.631. That's pretty close to 5. So that checks out. So this is my approximation. Okay? That is my approximation. So if I wanted to, let's say, find log, your book does some goofy ones. I think like log base pi of 400. Okay? Log base pi of 400. I could say this is ln of 400 divided by ln of pi. So ln of 400 divided by ln of pi. And I get roughly 5.23. I'd round that 9 to a 0, so it'd be 40. 5.2340. And again, if I want to check it, this should be pi to the 5.2340 should be roughly 400. Okay, I'm going to check that. Pi raised to the 5.2340. Yeah, 400.020670. That's pretty close. Okay, that checks out. So therefore, that is my approximation. Okay, we'll use this when we're solving. If we want to get an approximate value when we're solving, we're just going to pop it into this change of base formula. Okay, some textbooks or some calculators have it built in already. That's fine, but a lot don't. That's why I'm going over it. Okay, so for homework, 1 through 35, these are all going to be odd. 41 through 57, and then 71 through 77, And then this isn't that much actually, because it's all cut up. But look at 103 as well. Okay, so that's the homework. It starts on page 477. Page 477, 1 through 35, 41 through 47, 71. These are all going to be odd. Okay, all odd. So get that homework done. And then I will expect kind of questions actually. Tuesday when you get in, if you do this homework, this isn't the easiest section. This is actually one of the tougher sections. And then 4.4 we're going to solve now. So everything we've done in 4.2 and 4.3 has been about simplifying or finding approximations. We haven't solved for a variable with a logarithm or with an exponent. Okay, that's what we're going to wind up doing over the next section. Okay, I'm going to stick around, guys.